Hello guys, welcome to my channel. In this video, we'll dive into the world of an operating system. First of all, I am explaining what is meant by operating system, and then I am exploring about the fundamental concept of operating system and what what is called user mode and what is called kernel mode, and then what is meant by compiler, and then how the JVM actually works. First of all, I want to explain what is called operating system. An operating system is the brain of the computer that manages everything happening inside. The actual definition of an operating system is an operating system is a system software that manages all hardware and software resources on a computer. It acts as a bridge between the user and the computer hardware, enabling communication and efficient functionalities of an application. It helps it helps users communicate with the computer without needing to know how the internal part works. Uh, I am explaining with an example. First of all, think of like a manager of an office. You like a manager in an office. The manager assigns tasks to the employees, ensure work is done smoothly, and prevents confusion. Similarly, an OS manages files, application, memory, and devices like a keyboard, mouse, and printer. Uh, we will take another example to understand what is called operating system. Think of an operating system as a school. In the school, principal manages everything. A school has many teachers, students, classroom, and resources. The principal manages everything, assigns teachers to classes, ensures discipline, and makes sure all activities run smoothly. Here, the principal is the operating system, and all teachers, students, these are the functionalities. Teachers would not know their schedules, and students would not know get their right lessons without the principal. Similarly, an OS manages programs, allocate resources like CPU, memory, and storage, provide security. Here, manage programs means principal managing teachers and other stuff. Allocate resources like CPU, memory, storage means like assigning the classrooms and materials and all the stuff. Providing security means just like a principal enforces the rules of the school. This is what meant by operating system. It helps users to communicate with the computer without needing to know how the internal part works. The students and teachers did not know how the actually works, but on operating systems, all hand cares about that. Some real life examples of an OS means we all know we are using laptops. In the laptops, most of them have Windows as OS. Some of them has Mac, Linux operating system, um, etc. And now I am explaining some main functionalities of an operating system. As as the previous example, I mentioned that school as an operating system. Now the all functionalities happens here in the operating system also. In memory, functionalities, memory management, process management, device management, and file management. Memory management means the OS allocates space for different programs so they can run smoothly. It makes sure no program take up too much memory and slows the computer. Uh, yeah, next process management. Process management means multiple programs runs at the same time. Process means program under execution, like a browser, music player, or Word document. These all are in running at the same time. The operating system manage the process, which process to run in that time, or multiple processes at the same time. Some following some process management algorithms. The OS decides which program get how much processing power to avoid slowdowns. The process management in that functionality. Next, device management. The OS concepts and controls external devices like USB drivers, printers, speakers, etc. The all devices that are managed by the operating system. Next, file management. It helps to store, organize, and retrieve files efficiently, prevent accidental deletion of important system files. It protects with the some it protect with the unusual activities. The operating system ma- these are the some main functionalities of an operating system. Next, we will dive into the what is called user mode and what is called kernel mode. First of all, what is user mode? In the user mode, the uh, it is also called as safe zone. The kernel mode is the admin zone. This is the where normal applications like games, browsers, and text editors run in the kernel mode. In the user mode, sorry. What is user mode? First of all, it is a before user mode and kernel mode. These two. The CPU in computer operates in these two modes to ensure security and efficient execution of process. User mode is the restricted mode for application. Kernel mode privileged mode for operating OS operations. Uh, in user mode, applications like browsers, games, MS Words run with limited access to system resources. If a program crashes, it won't affect the entire system. Only that application will stop. Example, the OS prevents user mode from the directly accessing hardware like CPU, RAM, and disk. This is where application run in limited access to prevent accidental and harmful actions. User mode is the safest mode. While coming to the kernel mode, uh, kernel mode has full control over the computer hardware. In kernel mode, the OS has full control over the computer's hardware. It can directly access memory, CPU, hard disk, and other critical system components. Kernel mode is also called as admin zone mode. This is the core part of the operating system that has full control over the computer hardware. The OS runs in this mode with full control over the system, managing memory, process, and hardware. Example, think of a bank. Customers are in user mode. Bank manager kernel mode. User can only do basic tasks like withdrawing, depositing money, etc. But the bank management has full access on bank and can control everything behind the scenes. I'm thinking you got that. Next, what is called system calls? Uh, s- a system call is a way for programs to request services from the operating system. Programs need to ask permission from the OS to access resources like files, memory, or the internet. This is done through system call, a way of program to request the OS for help. System calls is the way of programs to request the OS for help. Example, if you want to borrow a book from your library, you request a librarian to get it for you. This is called system call with example. System call are categorized as process control, file manipulation. Wait one second. Mm. These are the some types of system calls. First, process control. In process control, we are managing processor for creating the process, terminating control over the execution. We have fork, execute, exit, wait system calls to do all the stuff. For file manipulation, hand in file manipulation, the system call handles the files like create, open, read, write, delete, etc. Next, device manipulation. In device manipulation, communicate with the hardware like printer, storage, network. They have different system calls like uh, read, write, open, close for device manipulation. Information maintenance, we can retrieve, update the system info like time, date, stats, etc. For communication, enable process communications here, data transfer, messaging, etc. We have pipe, send, receive, socket, like other system calls. For protection means ensure security, like controlling resources, access, user permissions, etc. Conclusion: system calls are the bridge between applications and the OS kernel. Without them, programs would not be able to perform basic operations like reading files, creating processes, or communicating over an internet. Next, I am going to discuss about compilers and interpreters. Uh, these two are used for translating code. Compiler converts the entire program into, first of all, we write a code in some programming language, but the system does not know about that language. It is in English language, but the system only understand only zeros and ones. Compiler converts the entire program into machine code before running or resulting in faster execution. Means it checks all the lines at a time and convert all the program at one time. Compiler translate the entire program at once before running. Before running, it converts the source code to machine code, machine understandable code. Next, interpreter does not do the thing like this. Interpreter execute code line by line, allowing for easier and debugging and platform independence. Compiler translates the entire program at once, but interpreter translates line by line while running. Compiler is the fast execution. Errors must be fixed before running. Examples are C, C++, etc. Interpreter executes translates line by line. It is easy to find errors, but slower than compiler. Uh, these are Python and JavaScripts are the examples for interpreter. Next, I am discussing steps for compiler. How the compiler converts the source code to machine code. First, it has 6 steps: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, optimization, and last code generation. First, what is called lexical analysis? Lexical analysis means it first we write the code in some English language. It breaks down the code into words like for individual single word. For suppose int a comma b comma c and semicolon. It divides int a and comma b and comma c and comma and semicolon as comma. It divides all the individual words to sub and separates it. Next, syntax analysis. It's check the grammar. In syntax analysis, the compiler checks grammar using syntax rules. If there is an error, it reports syntax error. For suppose int x equal to 10, if there is no semicolon, then it returns the syntax error. In lexical analysis, it divides into token, and then syntax analysis checks the grammar with syntax rules. And then semantic analysis. In semantic analysis, we check the meaning of the code after syntax validation. Uh, for suppose we are initializing int x equal to hello. Is it possible? No. Int is an int takes only numerical values. Here hello is the character. So it doesn't allow. Okay. Then next it checks and returns mismatched data type. So then it throws semantic error. In the fourth phase, uh, if these 3 steps are over, these 3 are satisfied, then we go to the intermediate code generation. Intermediate code generation converts code into intermediate representation, means IR. Uh, like a equal to b plus c, per suppose there is an syntax, it returns to add b c to a, means uh, add b comma c to a, means adds b comma c and store it in a. This is the translate into common format. Next, fifth is optimization. Makes code faster, improves the efficiency by removing redundant code and optimizing execution speed. In this step, it checks the code and make it faster. Next, final step is code generation. Creates the final machine code, generates the final machine code, the binary code that the CPU executes. Once all steps are done, an executable file is generated. And then next I am explaining about JVM, Java Virtual Machine. Uh, Java uses something called Java Virtual Machine to run programs on any device. Any device. Instead of converting Java code directly into machine code, JVM converts into byte code, which can run only any computer without with a JVM installed. Sorry. Uh, mm, JVM is like an universal translator. It ensures Java programs can run on Windows, Mac, or Linux without changes. If we convert the machine code to bytecode, the bytecode can execute in any operating system, Windows, Mac, or anywhere. First, we write the code, Java code, then compilation can be done. It converts the machine code to bytecode. After execution, JVM reads and writes bytecode on any system. After bytecode conversion, we can execute on any system in JVM installed computers only. Next, garbage collection automatically frees unused memory. Okay. Now some key takeaways of of the overall concepts. What is called operating system? We discuss about the operating system. The operating system, brain of the computer, managing everything behind the scenes. It allocates memory, control process, manages devices, and helps with file organization. User mode is the safe zone, and kernel mode is the admin zone. We already discussed about this. Program talk to the OS using system calls only. It talks to the functionalities of the OS with only system calls. Compilers and interpreters helps to convert human readable code into machine code, and JVM makes Java programs run on any device. These are the topics we have discussed about, and thank you.